for water and ice on the moon and Mars, because that's interesting scientifically. You know, how did we get ice on the moon, and why is there water on Mars, and how did it get there, and what's it doing, and where is it, and all of those questions. And then also for human exploration, because at NASA, of course, one of the things we do is we send astronauts out into space. And so when we are looking at sending astronauts to the moon and onto Mars, you start getting to Mars, it's pretty far away. So you start to have to live off the land is what you need to do. Kind of like when we started exploring the Americas, right? You don't bring everything with you on the ships that you need when you go, because it's expensive and it's hard. So if there are resources at the place where you're going that you can use to live, that is a much better option. So you don't have to carry everything with you, because that gets really expensive. So it turns out that water is one of the most important resources. And it's important because, I mean, obviously we need it to drink, we need it to live, you need it to brush your teeth and take a shower and, you know, all those things. But also it's important because it's a source of fuel, because water is, of course, H2O, hydrogen and oxygen. And the two components of rocket fuel are hydrogen and oxygen. So when we go to the moon and when we go to Mars, we want to find the water, because we want to use that water as a resource and then turn it into a fuel to not only, you know, provide energy for your base and for living, but also the fuel rockets for your return, you know, if you want to return back to Earth or go somewhere else, those sorts of things. So for those reasons, that's why I'm interested in water on the moon and Mars. It's for science, and it's for, you know, the next step in human exploration. So how I got here with this really fun and cool job is in high school, I didn't really know anything about space and we didn't really study it very much in high school. You all are very lucky that you're taking these classes already. And so I worked at the planetarium in my hometown in central New York. I was very lucky. I got to go to Spacecamp in Huntsville, Alabama, which was so awesome. It's still up and running if you ever want to go. There are scholarships you can apply for. It's really cool. You get to go and like learn how to fly space shuttles and spaceships and do all sorts of simulators and pretend you have low gravity and bounce around like you bounce on the moon and all sorts of very cool things. So I did that. And then I went to college at Colgate University in central New York. And that was a great experience because I got to study astronomy and physics, among other liberal arts topics, and then had the opportunity to do internships, which was one of the great things, to go and learn about different things. And so I did lots of internships studying galaxies and, you know, stars. And then I started working on planets and that sort of thing. So I studied that in college, and then I went on and got a master's and a PhD in planetary science. And then I started working at NASA, and here you go. So that's kind of the brief summary. And I did other things along the way, like I was a cashier at Wegmans, if you know what Wegmans is. I don't know if you have Wegmans where you are, it's a grocery store. I worked at the mall in the food court. I worked at the frozen yogurt store. I worked at Haagen-Dazs and scooped ice cream. I delivered newspapers one summer, you know, all those sorts of things. So a whole wide range of things. So it's, and I think some of the most interesting and best experiences were maybe not necessarily related to what I'm doing now, but you have to do a wide range of things to figure out what it is that you really like, right? So some of the things, you know, like, oh, I don't like doing this. That's actually good, because you learn, okay, maybe I don't want to do this forever. Maybe that's not what I want to focus on. That's not what I want to study. And then you can, you know, as you're exploring different things and different topics, you can kind of start to figure out, oh, I really like that. You know, and so that's kind of how it happened for me. I was like, oh, I did this one internship and I really was like, oh, planets, that's pretty cool. Oh, there's mountains on the moon. Oh, Mars has glaciers. Oh, that's interesting. I didn't know that. Oh, and these are places you can go and we can send people and you can like walk there. Oh, that's kind of cool. So I think an important part of it is just, you know, finding your path, and everyone has a different path. And that's part of the beauty of it, because you can figure out sort of what it is that you like to do, whatever your passion is. So maybe I should stop talking. I don't know.
It was great. Thank you. I would love to open it up to the students for questions. Folks, I know you are not shy. please. Some of you anyway are really willing to speak up. Others may not be and would prefer to put things in chat. But if you want to, let me do gallery view here. Does anybody want to jump in there and either raise your blue hand or speak aloud? Sophie.
Hi, I'm Sophia. I was wondering what your experience at Spacecamp was like and what the requirements were to attend and all that.
Yeah, so my experience at Spacecamp, I would qualify as life-changing because it was the first, so I went to Spacecamp, I think I was like a junior in high school, maybe something like that. And I like had all those jobs so that I could pay for it because it's not cheap. So, but it was the first time that I went somewhere where there were people like me who had the same like interest in space. Like at that point, I thought space was cool and I was like, oh, that's neat. But then I went to Spacecamp and I was like, wow, there are people like me who like really love this. And so that was one of the most important things, was finding a community of other people with shared interests. So I think that's really important. And then you can surround yourself with people who like are interested in, are passionate about the things that you care about. So that was great. And then the experience itself was awesome because it was a week, you know, and you lived in this habitat and you just did space things all day and you did simulators and you rotated through and you learned how to like fly the space shuttle. Cause at that time we were still flying space shuttles. So you learned to fly the space shuttle and you were like the pilot and the commander, and then you rotated and then you did science experiments on the space station. And then you did EVAs, the extracurricular activities, like when you're in the spacesuit and you go outside of the spacecraft and you had to like fix a satellite and all these things. And then you did rotation working in mission control so you could see what that was like. So it was super fun. I learned a ton and I met people, and that's when I realized like, oh, like people do this for a living. Like that's a thing. Like you could do this for, you know, for a living. So that was in high school, and the qualifications are you pay for it or you apply for a scholarship. So after high school, in college, because I loved it so much, I went back for a summer and was a counselor. And that was so awesome because then you go through like several weeks of training to learn how to teach, you know, the students how to work in mission control and fly the shuttle and all those things. It was super fun. So that was great. And then fast forward, it was a couple of years ago, and I was like, probably one of the biggest honors of my life was to be inducted into the Spacecamp Hall of Fame. I didn't even know there was such a thing, but there is. So sometimes, you know, alumni who go out and, you know, then pursue careers in space, you can get nominated and whatever. And so that's really been great. And so now I've been able to get more involved with Spacecamp. So now I'm on the committee where evaluating like applications for scholarships. And awarding money so that, you know, students can go and go to Spacecamp for a week. And they have all different levels. There's like, you can go in middle school, you can go in high school, there's family Spacecamp. There's Aviation Challenge, which I was always too afraid to do, but it looks really cool, where you're like jumping out of simulated helicopters and like parachuting into water and survival skills and all these things, which looks awesome. So there's that. And now there's also Cyber Camp, which is because, you know, computer science and computer technology and cybersecurity is so, you know, such a big thing these days. And it's a really hot career path. So now there's a cyber camp to get you, you know, exposed to that. So I have 2 thumbs up for Spacecamp. It's located in Huntsville, Alabama. They're still up and running. So because of COVID, they couldn't do space camps this year. And they're just kind of starting to come back. So there were a lot of, you know, like many things this year in 2020, there were fundraisers and trying to keep the center going. So they were able to do that. And it's also located on the same property as the US Space and Rocket Center. So even just going to that is amazing because it's got all these rockets and Saturn rockets and the Apollo rockets and things you can get in. And the museum is amazing and it's all hands-on and there's activities and that sort of thing. So 2 thumbs up for Spacecamp. And actually, Deb, I have some swag from Spacecamp and I can send it. I'll send it to you and you can, I don't know. I don't even know how this works these days. Like you can't hand it out in your class, I guess. But anyway, I'll send you stuff and somehow if people want it, maybe we can send it to individuals.
Yeah, I can figure that out because we'll be back in January. That's the plan anyway. And even though this class is a 1 semester class, I know that I'll see these students at some point in the spring, so we'll
Okay.
be able to do that. A question about the space camp though, does it run during the academic year or just in summers or whatever?
That's a good question. I'm not 100% sure. I know summer is their high season. I'd have to look. I want to say they have it all year, but I'm not 100% of what the schedule is. And it's all completely different now because of the COVID situation. They've had to really scale back, and they've done a restructuring, and, you know, some people aren't working there anymore because they couldn't keep everyone on staff. So I don't know what the current situation is, but I do know, because I just was reviewing applications for the scholarships, we're giving students the opportunity to defer, you know, till next year, whenever it's safe and whenever people are comfortable with going. Yeah.
I have a follow-up question that's related to this, which is our seniors, and there are many here, some are juniors. So these are all juniors and seniors. And then my dad is here too, who's the very senior there. But anyway, they in May have the opportunity to do a senior project, which is a month-long, 6-week thing, where they can typically go somewhere, intern. We don't know exactly what the landscape is going to look like this year, but in terms of that, if they were able to do space camp, maybe they could. But if you were a senior in high school, or you were advising a senior in high school, if they were interested in a career like yours, what kind of thing could they spend that month and a half doing? Are there opportunities that you can think of that would be good preparation for them, or cool?
Yeah, oh yeah, that's a great question. I would think about that. So yeah, I mean, going to somewhere like the Space and Rocket Center is amazing, because you get exposed to so much and such a variety of both the human spaceflight and the robotic spaceflight side of things. So you would learn a lot. There's also, you know, it depends on, I guess, how far you want to travel. NASA centers. So like NASA Goddard, you could come to NASA Goddard, and there's a visitor center there. And sometimes you can get tours, although again, everything is, you know, up in the air. I don't know what the situation is, but normally you can get tours, and you can go see the high bays where the spacecraft are assembled, like in clean rooms, because we have to keep everything very clean before we launch it. You can see like mission operation centers at NASA Goddard. So that's in Maryland. So I'm thinking that's closer to you. Most of the Earth observing satellites that NASA runs are operated out of Goddard. So there's this huge operations center where, you know, it's people sitting at consoles and monitoring what's going on with the orbiting spacecraft, you know, like spacecraft where you get your nightly weather forecast and how you know it's going to rain tomorrow. And, you know, how do you know that it's going to snow? So you should put your car inside, or, you know, is there going to be school tomorrow? Because is it going to be a snow day? Like NASA operates those spacecraft, most of them. So that's how we get that information. So that's a good thing to do. The local, you know, if you have local museums or planetariums, that sort of thing, that's always a helpful thing. There's a lot of online resources as well, which is useful. NASA has a lot on, you know, online. And then there's also the connection to ongoing and future missions. So there are projects you can do that you don't even have to travel. So for example, I'll just throw this out there. There's one mission that I'm working on right now. It's called the Viper mission. It's going to the moon. We're launching in 2023. And Viper, it's an acronym because it's NASA. Even NASA's an acronym. Does anybody know what NASA stands for? Pop quiz. It's the National Aeronautics and Space Administration.
Class, so, you guys got to speak up. You make me look bad.
So Viper stands for the Volatiles Investigating Polar Exploration Rover. So volatiles is a fancy word for cold ice. So what we're doing is we're sending a rover, a robotic rover, to the South Pole of the moon to drive around and map out where the ice is. Because remember, I told you in the beginning, we care about ice because, like, where did it come from? How does there ice on the moon? First of all, we didn't think there was ice on the moon until like 10 years ago. Because the moon is super cold. There's no atmosphere to keep water or ice stable. And it's super dry in most places. We have samples from the Apollo mission, right? When humans went and returned samples, and we've analyzed them, and like they're dry, like great. But now we've learned near the poles of the moon, actually, let me get my moon. Here's my moon globe. So near the poles of the moon, North Pole and South Pole, so you should know this from some of your dynamics, right? the rays of the sun are coming in like this, right? So they're coming in at a very low angle. So they're coming in at a low angle, so it's very, very cold, right? Because think about the seasons on Earth. You know the reason for the seasons. You get a high sun angle, you get intense sunlight. So at the poles, the sun is basically skimming across the poles, and there are a lot of craters all over the moon. So like bowl-shaped depressions. So there are a bunch of craters at the North Pole and the South Pole where the sunlight is coming in and it's skimming over the top of those craters, and it's never actually reaching the bottom of the crater. So the bottom of that crater is in permanent shadow, permanent darkness. And I'm talking for billions of years, billions with a B of years of never seeing sunlight. So you can imagine that the bottom of those craters are very, very cold. And so since they're very, very cold, and they've been cold for billions of years, it's a really good place to trap ice. And so that's where we're finding a lot of this ice, as in these, we call them PSRs, another acronym, permanently shadowed regions, right? So it's just a fancy way to say where there's no sunlight and it's super cold. So we're taking a rover and we're going to drive around. We're actually, because of when we're launching, we're going to the South Pole. We're going to drive around the South Pole and map out where that ice is. So one of the things that we're doing now, and it has not been done, but it's a good project for us, and it's a good project, that you could work on, is one, where do you go? Where would you actually land? Like, which crater would you land near? Where would you want to go? And then two, you have to plan that traverse path for that rover. Like, you literally have to plan out where it's going to drive. And so you have to take into account things like, how steep is the slope? Like, don't drive over a cliff. Make sure that you can always still see the Earth so you can communicate with the Earth. Do you need to go back to sunlight to get solar power? All of these things that are layered in, and there are online tools. One of them that you might want to check out, it's called Moontrek, Moon and then TREK, I think. Anyway, it's a NASA database that we've been working on, and it has all sorts of different data layers in it. The amount of rocks, for example, don't drive your rover into a big rock field where you're going to get stuck. So it's like really basic things. Like if you thought about you were going to take a little robot and drive it in your, out in a park or something, or in a yard or down the road, like don't go over a bunch of rocks. Don't go on a steep slope where you're going to tip over. Make sure you can still communicate with it and tell it where to go. And go somewhere where you think that there's going to be ice. So that's exactly what we're trying to do right now, is put all of that together and figure out where to go. So we haven't figured it out yet. There's no answer yet. We don't know where we're going to land. We don't know where we're going to drive yet, but we're trying to work on it. And there will be an open meeting, because this is one of the things we like to do, is ask people, like, what do you think? Like, where should we go? Like, go to Moontrek and look at all the data and then tell us where you think we should go. So probably sometime early next year, there will be an open, anybody can come meeting to talk about this and for people to present their ideas. So you might come up with some ideas, and then you can dial into that Zoom meeting and see what other scientists say. And it's really fun, because then you get to talk to people like, oh, well, at your site, did you think about this? Or did you see that there were too many rocks here? Or can you get over to that crater there? That sort of thing. So that's just how we do it. That's how we figure these hard questions out, is we put all the information out there and we say, okay, people, go work on it, work on the problem, come back with your best solutions, your best ideas. And then we present them to each other, and then we discuss and ask questions and try and come up with the best answer. So that's like one example of the types of things that we're working on that you could actually contribute to. And then you can watch the mission launch in 2023 and then follow, as we drive the rover on that path that's been predetermined, based on this sort of process of figuring out, where's the best place to go? Because we don't have all the answers. That's just, not how science works. One person doesn't have all the answers. It's a group effort, and everybody brings a different perspective into it. And that's specifically why we're having this sort of open meeting, putting it out there. Like, here you go. Here's the list of constraints, low rocks, make sure you can see the sun, or not the sun, make sure you can see the Earth, make sure you're in the sun enough to get solar power for our batteries. Yeah, don't drive it off a cliff, and go where there's ice. Those are the big ones.
Thanks.
So.
That is really cool, and we definitely will be watching the launch at Friend Central. Although everyone here will have graduated by then, but other students will be around, so we'll be watching that and definitely following it. So what's interesting and really relevant, Jen, is that these students are all right now, their assignment this week is they're working on developing their own missions with their own acronyms, and some of the constraints that you just placed are, you know, things they're thinking about in terms of planning their missions to a fictitious system called Glucas 1, G Lucas 1, with planets like Devader and all of those things. So yeah,
Nice.
you get the thing. So folks, are there other questions that you have that you thought of before or thought of as Jen was talking that you'd like to ask her? Botini.
Yeah. While you were talking about how you discovered your interest for space in high school, I was wondering, did any interests you had before steer you to that, or was it kind of just like like I worked at a planetarium and I now like this a lot and I want to follow it?
Yeah, you want to know the true answer? When I was about 10, the movie Spacecamp came out. Has anybody seen the movie Spacecamp? It was in 1986. Oh. Okay, well, you should go watch Spacecamp. It's a highly unrealistic movie about kids that go to space camp and they accidentally get launched into space on the space shuttle. But putting all of that aside, I was like, whoa, that's so cool. And so I watched Spacecamp when I was 10. And then I really didn't study planets ever again until college, or study astronomy until college. And then I went to college, and in my first semester, I signed up for this astronomy class because I was like, well, I got to do some science and I like space camp. So let's sign up for astronomy. So it was not like, you know, it wasn't like I was one of the, you know, I'm going to do this and that's what it is. It's like I'd watch Spacecamp and then I would make my friends play Spacecamp with me. And I would, like, you know, get calculators out and pretend it was a space shuttle cockpit. Like, you know, when you're like 10, like that's, you know, whatever, that's what you do. And then I started studying this in college, really having no idea or thoughts about a career path. I just was like, oh, I like this. Sure, I'll take astronomy. I guess I have to take physics too. Okay. And then, you know, my advisor said, you got to take the math too. And I'm like, okay. So just kind of going on that path, but it was really interesting. And then I think one of the important things is being able to have good mentors who can help you, because there's no way you can know what's out there, first of all, and what you're supposed to do or what your options even are. Because especially for you all, I mean, what you're going to end up doing as you go through college and beyond, like, I mean, your jobs may not even be invented yet, right? They may not even exist. Like, things are changing so fast and things are developing so quickly. So just finding like the sort of topics that you like and like what classes make you, you know, interested in that you're looking forward to and the things that you want to work on. I think that's really important. And what are the things that you like to do, like in your, you know, spare time? Like I like to pretend I was in a space shuttle, like, okay, you know, so just kind of having those experiences and trying to follow through, and then being able, like, fortunate enough to find people who can help you, whether that's like your teachers or when you get into college, some of your professors who can say, hey, you know, have you thought about applying for this thing that you would have no idea of knowing existed, right? Have you thought about maybe working on this? Have you talked to this person because they do things that you seem to be interested in? And just kind of trying to see what's out there and figure out where you kind of want to go.
Thanks. Awesome advice. And I think Tom Bolanek probably made astronomy so cool in college that he was the professor of astronomy there at the time at Colgate that attracted you. Yeah.
Yeah, and it was super important because he would say, hey, have you thought about, hey, there's this summer internship job. And I was like, what's an internship? You know, it's like, oh, wait, they'll pay me all summer to like go study astronomy?
to work with
Okay.
me. That's how we met,
Exactly.
right? To come work with
Yes.
me.
Yes, and it was fantastic. It was like the best. I'm like, oh my gosh, you can do this. I don't have to bag groceries all summer. I can go like,
Play with a telescope. Yeah.
work on a telescope. Yeah, it was like very eye-opening. It was super great. So just, having those experiences to learn like, oh wow, like you can actually go out and do this and people will pay you too.
Mm-hmm.
So that's kind of, yeah.
All right. Any final questions here? Really, in our last moments, maybe Jen, can you tell us a little bit about Antarctica and working there?
Yeah, so that's another one of the benefits of my work that I didn't anticipate before, is that I've gotten to go to all sorts of places on this planet, Earth, that most people have never been to and that I never thought I would go to. So I've been to Antarctica, I've been to the high Arctic, like places like the Atacama Desert in Chile, Svalbard, which is like north of Norway, all sorts of places. And the reason that we go there is because we do what is called analog work. So basically, I want to understand, for example, how water flows on Mars. How does it work on Mars? Well, right now we're not sending people to Mars. So the next best thing is to go to somewhere on Earth that is like Mars. So being like Mars means it's very, very cold and it's very, very dry. And it turns out in Antarctica, there are places called the dry valleys, which you think of most of Antarctica is covered in ice. That is true. But in the dry valleys, it's ice free and it's just rock and dirt and it's super cold and it's a polar desert, meaning it's super dry. And so Antarctica is arguably the most Mars-like place on Earth. So I've gotten to go to Antarctica to do studies of, okay, how does ice behave in these very cold and very dry places? So, what are the temps? So I put temperature probes like underground, like what are the temperatures and how does it change over the day and over the season? And where is the ice and why is it there? Because then if you can understand the physics behind why the ice is behaving how it is in Antarctica, you can take that physics understanding and apply it to Mars and say, oh, this is what the ice is doing on Mars. So that's part of it for science. And then also we take our instruments and test them on Earth before we send them to Mars. So for example, we have taken drills and we've taken instruments and, spacecraft components because it's a whole lot cheaper and a whole lot safer to test them on Earth before you put them on top of a rocket and launch them to another planet. So we do that a lot. And so we do a lot of testing in Earth analog locations because it's hard. I mean, it's still hard in Antarctica. Like they literally, you get in a helicopter and you pack everything you need for 6 to 8 weeks. Food, fuel, tents, all your science gear, everything you need to survive. And they fly you to the dry valleys. It's like 2 hours out of McMurdo Station, which is the US base there. And then they dump you and all your gear and they literally throw it out of the helicopter and they fly away. And they're like, we'll see you in 2 months. So you better make sure you've got everything that you need. And so it's not easy to do this testing with like, big drill systems and that sort of thing. Like it's still hard. And that's why it's good, because it is hard, because it's even harder on Mars. So we go and we do all of this work and we do all this testing. But in the meantime, it's amazing because as a planetary scientist, I get to go see all of these beautiful, fascinating, amazing places on Earth that are not tourist destinations that you can't just take a flight and get to. And it's really been probably one of the best parts of my job, I think, is learning more about our planet by studying other planets.
That is a perfect way to end it. And I promise I did not prompt her with that last sentence, although I've been saying it like 17 million times this past week, is that, studying other planets helps us understand Earth. Studying Earth helps us understand other planets. It's kind of circular. Absolutely. And with that, we will say thank you. The class goes till 12:15, so I'm going to keep them here to do one other activity. But thank you so much for joining us. It was awesome to see you again.
Thank you so much, and good luck. Let me know if you have any follow-up questions, and I'm going to get my Spacecamp stuff out to send.
Thanks, Jen.
Thank you.
Bye. All right, everybody else stay. Thank you for being here and being a good audience for her.